Okay, guys. So let's get started without any further ado. Before we do so, again, a quick formal introduction on my name is Mohammed Shoaib. I'm going to be your cybersecurity trainer for the rest of the course as well. And again, I've been certified from EC Council. I've completed certifications such as CEH, and I specialize in web application pen testing as well. Now, I've been teaching students since the last 4 to 5 years or so. Okay, and again, I've been working with a lot of institutes. One of them is DURGASOFT and a couple other Mumbai-based institutes as well. Okay. Now, coming back to this, as mentioned, when we talk about networking fundamentals, there are three important definitions to know. What is networking? What are networks? And what are hosts? So, when you talk about networking, this is the practice, I would say, of connecting information devices with each other to share resources or data. Okay. Now, these information devices can be anything, and they are called as hosts. Okay. So, host refers to any information system which is capable. Oh, sorry. Coming to a network first. When you talk about a network is a collection of these interconnected devices, your computers, your servers, printers, etc., etc. A group of these interconnected devices with each other is called as a network. Okay, and this group can transmit data to each other, and each of those endpoints or each of those devices is called as a host. Okay, so again, as an example, your computers, your routers, your firewalls, your databases, your servers, your smartwatches, your smartphones, your speakers, okay, iPad, smart cameras, IP cameras, tons and tons of devices. So each of these individual systems refers to a host. Okay. Now, just like how we have our names, our unique names to address each other and recognize each other by, these devices also have names. And that name is called as an IP address. It stands for Internet Protocol Address. So to define it, each host on the network has a unique identifier known as an IP address, and this allows for communication to occur between the hosts. So the identification, the recognition of each device in the network is done by IP addresses. And these IP addresses have a few important properties to them. Initially, they were built by the US military in the 1950s or so, and there were multiple versions of it: IP version 1, IP version 2, IP version 3. They didn't work out successfully. What properly worked out was IPv4, Internet Protocol version 4. And they're still using IPv4 even in today's world. Okay. And this IPv4 address has a few important properties to it. Okay. Firstly, it's a 32-bit address. Now, what I mean by 32-bit address is that it contains 32 zeros and ones. So a bit is the smallest data value a computer can store. Okay. And it can either be the value of zero or it can either hold the value of one. Okay. So when you talk about an IPv4 address specifically, it contains 32 bits in it, 32 zeros and ones in it. And this entire 32-bit address again is divided in four equal parts, where each part consists of 8 bits, and that 8-bit portion is called as an octet. Octa represents 8. So octet in the sense 8 bits. Okay. And each octet here is separated by a dot symbol. So as you can see, this is what an IPv4 address looks like in the binary format. Binary in the sense language of zeros and ones. So 8 bits here, then a dot, then 8 bits here, then a dot, then another 8 bits here, then a dot, then another 8 bits here. Okay, so 8 fours are 32-bit address. So this binary address can actually be converted into human readable decimal addresses as well. So this number here, 11000000, is actually equal to 192 in human readable language. This number 10101000 is actually equal to 168. This number, all zeros, is equal to 0. And this number 00001010 is equal to 10. So now we're going to learn how do you convert any such binary number to a human readable decimal number. Okay. Any questions or doubts up to this point, guys? Faisal, Dinesh, Rajneesh, Srinivas, Om Prakash.
No, sir.
Perfect. Moving forward. So let's talk about the conversion of how do you convert any binary number to a human readable decimal number. And I'm also going to explain why this is important. So this is quite crucial to understand, guys. Okay. So now, whenever you want to convert any binary number to a human readable decimal number, there are two simple rules to it and two simple steps. So if this is my binary number here, 10101010, 8 bits, as you can notice. So if you had to convert this 8-bit data, this binary number, into a human readable decimal number, firstly, you would assign the power of 2 to each bit from right to left, starting at 2 power 0 and going up to 2 power 7. So under the rightmost bit, you have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, you're assigning the value of two parts from 2 power 0 all the way up to 2 power 7. Okay. Now, if you specifically ask why only 2 to the power, this is a binary address. You have only two possibilities, cause either 0 or 1, hence the number 2 power. Okay. Once you have assigned these values now, you multiply each power value at the bottom to the upper bit, and then you keep on adding it till the end. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. Now, if you calculate this out, let me write down the values for these numbers first from 2 power 0 to 2 power 7. Anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2. 2 power 2 is 2 into 2. That is 4. 2 power 3 is equal to 2 into 2 into 2, 3 times. That's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times. That's 16. 2 to the power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Okay, so you have to remember these values, guys, to calculate binary decimal. So now once you have these values, 2 power 0 into 0. 2 power 0 is 1. 1 into 0, that's 0 itself. Plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2 itself. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. Okay. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer doesn't understand it that way. What it understands is binary numbers. So when you enter that number 10101010 in binary code, then it understands, okay, this is the number 170. Okay. So in human readable language, 170 is equal to 10101010 in computer readable language. Okay. So it's something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. So when that exact sequence of frequencies flow, the computer understands it as the number 170. Okay. So that's the conversion, guys, from binary to decimal. So if you have understood this, I have two other numbers here, binary numbers. If you have a pen and a paper beside you, I want you to convert these values and give me the decimal answers for it. 0, 1, 0, 1, 0, 1, 0, 1, and all ones. Okay, take your time, no rush. I want you to give me the answers for these two numbers. I hope the procedure is clear, guys. Any questions regarding the procedure? Does anyone want me to explain it again? Okay, perfect. Take your time, give me the answers for these two binary numbers. Okay. Any answers, guys, for the first one or the second one? Okay, perfect. So again, first one, I've got some couple of answers as well. 85. Someone mentioned 252. Someone mentioned 255. Let's verify. So the first one is right, guys. All of you have given the right answer. So again, same logic. 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0, as so on and so forth up to the last value. So 2 power 0 into 1, that's 1. 2 power 1 into 0, 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0 again. So if you add all that up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Correct answer. Okay. And when you have all ones, you just add all the values. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that gives you the number 255. Okay. Minor miscalculation here or there. But again, if you've got the logic, that's more than enough, guys, frankly speaking. Okay. So the reason I've been explaining you all this is now to get the range of IP addresses. Okay. What I mean by range is what's the first IP and what's the last IP. So if you had to get the first IP, all you have to do is simply put zeros everywhere. So in the first octet, all zeros. In the last octet as well, all zeros everywhere. And when you put all zeros, the first IP address in decimal would simply be 0.0.0.0 because you have all zeros in binary. So 2 power 0 into 0 plus 2 power 1 into 0 plus 2 power 2 into 0, everything would eventually just be a 0. Okay. And if I had to get the last IP, I just put all ones, the maximum number. Okay. And when you put all ones, you get the number 255. Okay. So from that binary to decimal conversion, now you have understood what could be the first IP and what could be the last IP. Okay. So first IP is 0000, and the last IP is 255, 255, 255, 255. Okay. And no IPv4 address can exceed the number 255 because when you convert any binary to decimal in any octet, the maximum it can go is 255, not more than that. Okay. And if someone ever asks you how many IPs are there in total, so each octet has two possibilities here, if you notice. Sorry, each bit in the octet. Okay. Two possibilities here, two possibilities here, two possibilities here, two possibilities here. There are 32 bits as such. Okay. So the total number of IPs would be 2 raised to the power of 32. So 2 into 2 into 2 into 2 into 2. Like that 32 times. And that would give you a number 4.3 billion IP addresses approximately. Okay. So again, if you talk about 4.3 billion IPs in today's world, it definitely seems a bit short. Okay, because the population itself is 8 billion people, and there's again multiple devices can be owned by one single person, right? So 4.3 billion IPs would seem insufficient in today's world. But no, there is a concept of classification of IPs, guys. So these 4.3 billion IPs are again divided in various categories. Okay? And some IPs can be repeated. So we'll talk about all that in the upcoming sessions, don't worry. But today we'll talk about the sequence of IPs as well. Okay. So now we know this is the first IP. We know this is the last IP. And there are a total of 4.3 billion IPs. Let's talk about that sequence now. Okay. Any questions up to this point? Anyone? Om Prakash, Ganesh, Faisal, Rajneesh. Okay. So in order to understand the sequence of IPs, guys, again, two simple rules. Rule number one, you always start incrementing from the rightmost octet. Now, what do I mean by that? So let me open up a list of IPs first. Just a second. Yeah. So now if we all know the first IP is 0.0.0.0. That's the first IP. So if you had to get the next IP after that, rule number one is always increment from the rightmost octet. So this rightmost octet increases by 1. So after 0000, next IP would be 0001. Next IP 0002. Next IP 0003. Next IP 0004. Okay. Like that, it keeps on going. And somewhere down the line, you would have 000 253, 254, 255. Now, after this, can I have a value like 0, 0, 0, 256? Is this possible? Can we have 256 in any octet, guys? Definitely not, right? Because the maximum number you can achieve in any octet is 255, not more than that. Okay. So once it reaches the maximum value here, then comes rule number 2. After the right, or once the rightmost octet reaches the maximum value, then you move to the left octet. So this left octet now, beside 255, this 0 now changes to 1. And this 255 cycles back to 0. It comes back to the first value, or resets back to 0. Okay. Now, after 1, 0, don't directly jump to 0, 0, 2, 0. That would be wrong, guys. Okay. Remember, rule number 1, always increment the rightmost octet. So after 1, 0, you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Goes up to 1, 2, 5, 5. Okay. Then you have 2, 0. So this 255 cycles back to 0. And this 1 now increments by 1. Okay. So you have 2, 0. Then 2, 1. Then 2, 2. Then 2, 3. Okay, goes up to 0, 0, 2, 2, 5, 5. Then 3, 0. Then 3, 1, 3, 2, 3, 3. Goes up to 3, 2, 5, 5. Then 4, 0. Goes up to 4, 2, 5, 5. 5, 0. Goes up to 5, 2, 5, 5. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 2, 5, 4, 0, which goes up to 2, 5, 4, 2, 5, 5. Then 2, 5, 5, 0, which goes up to 2, 5, 5, 2, 5, 5. Now both these octets are filled. What happens next? They cycle back to zeros, and the next octet 0 changes to 1. So you're back at the first IP again. So 0, 0. So if you notice here, we had 0, 0 again. Okay. So whatever repeated from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, same cycle repeats again from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Okay. So again, 0, 0, 0, 1, 0, 2, 0, 3 goes up to 0, 2, 5, 5. 1, 0, 1, 1, 1, 2, 1, 3 goes up to 1, 2, 5, 5. Like that, the cycle keeps on repeating. And therefore, from 1, 0, 0, you go up to 1, 2, 5, 5, 2, 5, 5. Then 2, 0, 0, you go up to 2, 2, 5, 5, 2, 5, 5. 3, 0, 0, you go up to 3, 2, 5, 5, 2, 5, 5. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 2, 5, 4, 0, 0, 2, 2, 5, 4, 2, 5, 5, 2, 5, 5. Then 2, 5, 5, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5. Now all these three octets are filled. So what happens next? They cycle back to zeros, and this 0 now changes to 1. Okay. Now whatever cycle repeated from the first IP, 0, 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. Same cycle now repeats from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. Then 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5. 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5. 4, 0, 0, 0 to 4, 2, 5, 5, 2, 5, 5, 2, 5, 5. And similarly, finally, 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. Here's the first IP, and here's the last IP. Again, that is how the IPs progress in a sequence. And if you count each individual IP, you would get a total of 4.3 billion IP addresses. Okay, so that's the sequence, guys. Again, quite important to know in the upcoming sessions. I'll explain why. Okay, but this is the entire sequence of IPs from the first IP till the last IP. Okay. Any questions, any doubts up to this point? Danesh, Faisal, Rajneesh, Srinivas Rao, Om Prakash. Does anyone want me to explain it again, guys? I see a lot of confused, I'm not confused, there's a lot of silent mics, muted mics. Om Prakash, any questions? Okay, okay, cool. Although might need some revision, I suppose, but no worries. If it's clear for now, perfect. Srinivas, any questions? Danesh, any questions? Faisal, any questions? Who else? Rajneesh Kumar, any questions? Okay, perfect. Right. Moving forward, now we have learned about the sequence, as mentioned. these entire range of IPs again are divided into something called classes, guys. So there's categories in them. So to categorize, firstly, there's something called classes: class A, class B, class C, class D, and class E. So there are 5 important classes, guys. Again, in each of these classes, there are 2 subcategories: public and private IPs. So in class A, there's public and private IPs. In class B, there's public and private IPs. In class C also, there's public and private IPs. In class D and E, you don't have any private IPs at all. All of them are public IPs itself. Now, don't worry what these public IPs are, what these private IPs are, what these classes are. We'll discuss them slowly, one by one. Okay. So let's talk about public and private IPs first. What are public and private IPs? So to understand public and private IPs, let's take the example of this network here. Okay, so let's say there's a home network. Let's assume this is my home here. Now in my home, I have multiple devices. I can have my phones, I can have my laptops, I can have my smart TVs, I can have my router. Okay, all of these are my local area network devices, my private devices. Okay, so each of these devices in my local network gets a private IP. Okay, so private IPs are the IP addresses assigned to each device in your local network to identify each individual system in your local area network or your intranet. Okay. Now, when any of these devices wants to communicate with the internet, guys, okay, so when my phone or when my laptop wants to communicate with the internet, and if they're connected to the Wi-Fi, they'll always send the packet to the Wi-Fi router first. And this Wi-Fi router gets a cable from outside your house. Okay, it could be an RJ45 cable or an optical fiber cable, which are running right now in today's era. Okay, so this optical fiber cable comes from the ISP, Internet Service Provider. So you have ISPs in India like Airtel, Act Fibernet, Hathway, BSNL, etc., etc. In United States, you might have ISPs like AT&T, T-Mobile, Verizon, etc., Mint Mobile. All these are ISPs in US. Okay, so these ISPs have one main task: they provide you the service of internet, and that is possible with something called a public IP. So your router gets a public IP from the internet to go to send packets to the public network. Okay, so this is your private network here, and this is the public network here. On the public network, you have all the websites and all the again web pages posted. Okay, so when my phone wants to communicate with google.com, it first sends a packet from its private IP to the router's private IP. From the router now, the packet transfers to the public IP. So the router's job is to connect between 2 different networks. So it sends the packets from the private network to the public network and vice versa. Okay. So your router sends the packet or transfers the packet from a private IP network here to a public IP. And from there, it goes to the ISP. And from the ISP, it reaches the intended web server. Okay. So the packet first travels privately in the private network here with the private IPs, and then from there, it shifts with the public IP to go to the exact web server. Okay. So to define these IPs now, public IPs are the IP addresses that are globally unique IP addresses, and they're used to identify devices on the internet. They're allocated by the internet service providers, and they're routable over the internet. So whenever you want an internet connection, you always need a public IP. And if you want to search what your public IP is, you can just go to your browser and search for what is my IP. Okay. And that provides you your public IP address. Okay. So this is my public IP 49.204.239.250. And this is provided to me by my ISP called Beam Telecom in my state Andhra Pradesh in the country India. Okay. So this is my public IP provided to me by my ISP. Okay. On the other hand, when you talk about private IPs are used within private or local networks, such as home networks, offices, organizations for local communication. They are not directly accessible from the internet, guys. So in order to connect to the internet, just a private IP would not be sufficient. Okay. So you need a public IP for internet connection. Okay. The private IPs only allow devices within the same local network to communicate with each other. Okay. So if I have a network of 10 devices over here, and if these 10 devices had to communicate with each other in the local same network, for that private IPs are sufficient. But when these 10 devices want to communicate with the internet, then you need a public IP for that. Okay. And if you have to figure out what your system's private IP is in Windows, the command is ipconfig. And you run this command in the command prompt. So you can just search over here for command prompt. You get the first suggestion here. And in that, you can search for ipconfig. Stands for Internet Protocol Configurations. And now when you hit enter, you can see this is my private IP 192.168.0.5 given to my Wi-Fi adapter. Now, why am I getting 192.168 here? Why am I getting 49 dot something here? It's because there are certain ranges, guys, for each public and private IP. Okay. So if you remember, there's something called as classes. Okay. So classes are again, there are 5 categories again: class A, class B, class C, class D, and class E. Okay. Class A starts at the first IP 0000. Class E ends at the last IP 255, 255, 255, 255. And in each of these classes, again, there's a set of private IPs. Okay. And all of these ranges are fixed, guys. They have been fixed by the people who invented IP addresses. And it's important to remember these ranges. Okay. So don't worry, I'm going to show you an easy method in the upcoming sessions to on how to remember these ranges. You only have to remember 4 or 5 numbers. That's all. Okay, and you get the entire range. But again, as mentioned, so the entire range of IPs from 0000 to 255, 255, 255, 255 is divided in 5 classes: class A, class B, class C, class D, and class E. Okay. And in each of these classes, again, there's 2 subcategories: public and private IPs. So if you remember this image earlier, as mentioned, 5 classes, and in each class, 2 subcategories: public and private, public and private, public and private. Class D and E are exceptions. They don't have private IPs. Okay. So we're going to talk about these ranges. I'm going to explain what these ranges indicate and all in the next session, guys. Okay. So yeah, that's that. Nothing further for our session. A brief introduction on what IP addresses are, what are the range of IP addresses, what are the categories of IP addresses, what are public and private IPs, what is the sequence of IPs, okay, and what is basically networking. Okay. In the upcoming sessions, in the next session, we'll talk about these classes. We'll talk about the relevance of each of these classes. Okay. What are classes? What is class A? What is class B? What does class C signify? Okay. And some important protocols. Okay, what is subnet mask? What is DHCP protocol? Okay, what is a DHCP server? What is a DNS server? Okay, we'll talk about all these in the upcoming sessions. Okay, so yeah, nothing further. A short session. Since these are demos, guys, we'll be taking slightly shorter sessions for all the students to slowly join and come along. And yeah, in the second session and tomorrow's session, we'll be completing some of the more important concepts in networking. Okay, so any questions or doubts up to this point? Faisal, Dinesh Babu, Rajneesh, Srinivas, Om Prakash. Yeah, Om Prakash. Any? Mhm. Yeah, beyond your router. So basically, your router actually gets the public IP. So when you see that cable from outside your house and coming and connecting to your router gets the public IP as well. Okay. So on one interface, your router has a private IP, and on the other interface, it has a public IP as well. Yeah, Prakash, go ahead. Private IP, exactly. Good question. So there are multiple ways of assigning a private IP. So there's a manual method, there's an automatic method. In today's world, all your routers perform the automatic assignment. There's something called as a DHCP server, dynamic host configuration protocol server, and that protocol assigns a private IP, each unique private IP to each system in the network. And we'll talk about that in the next session. So you'll understand then how these devices are getting a private IP automatically and how each device is again maintained a record of it. Yeah. Right. Any other questions, others? Faisal, any questions? Rajneesh, any questions? Danish and Srinivas have mentioned there's no questions. Okay, cool. So yeah, that's that. Nothing further for our session today, guys. Tomorrow we'll be connecting back at the same time and we'll learn a lot more important concepts. We'll talk about these classes. We'll talk about these DHCP server. We'll talk about DNS server, what they stand for, what they are, why they are relevant in a network. We'll talk about all those important concepts in the next session. Please do join tomorrow without fail. It's an important class. Okay. Bye bye. Take care. See you tomorrow at the same time. Bye, guys.
Thank you, sir.
Good night, Prakash. Bye, Faiz. Bye, Rajneesh. Bye, Srinivas.